Hello everyone, my name is Vikas Kumar Singh and once again we are back here to solve the assignment from the chapter from the course Mechanics of Sheet Metal Forming, and today we are going to solve assignment number 4. Now the question from assignment number 4 is from the sheet metal forming chapter where stamping, coining and all process are there. So if you are following the textbook, then the chapter number 4 itself um, contains all this concept. Chapter number 4 from the textbook, the text author name is Marciniak. So I would suggest please go through that book. That is very much helpful. So let us start with the assignment problem. So the first question here is from we have to find out the traction here. So in the question, a sheet material of 0.8 mm thickness, initial thickness, is stamped to a particular shape. The material follows a stress strain law. So this is the formula which is being followed in this problem, and K is MPa. So basically K is this one, this value, as if you are following the course, so you might be knowing all this. For a plane strain mode, okay, at a particular location, a 5 mm circle is printed. A 5 mm circle is printed somewhere on that sheet on the surface, deformed to 7 mm in major direction. So basically, it is given like in major direction, one strain we can easily find out because we know a strain equal to ln of L1 by L2 or T1 by T2. So this value is given here, so we can find out in the plane strain mode deformation, find the major traction at the location. Keep the final value in Newton per mm. So we have to find out the traction. Okay. So if this one is given here, this formula is given here. Here sigma effective is given and epsilon effective is given. And K, basically K, this value, it is given here as I already told. So K is 180 MPa. N is also given. This value is N. This is not minus 0.22. It's epsilon bar and whole to the power. This is like this. So whole power you can see like this. Okay. So don't confuse. So n equal to 0.22 and epsilon is the true strain. This power law follow this is okay. This is from the book theory chapter. So what is the strain here? So final surface deformation is given 7 mm and initial is given 5 mm. So we can find out the strain. So that strain value is 0.336 value, but this is not the effective strain. This is whatever we are calculating is the true strain. Now, what is this is the major strain due to the increase in the diameter of circle from 5 to 7. Next is we have to find out the traction. So if you are following that Marciniak book, so in the chapter 4, you have seen the equation number 4.7. So this formula, this big formula is derived there. Okay, so this formula is given there. So if I'm going to derive all this thing, it will take time. So I have taken from there. Okay, here beta is your strain ratio. Beta is the strain ratio, epsilon 2 by epsilon 1. Here epsilon 2 by epsilon 1, this is the beta value. Okay, and n is given, k is given, and this epsilon naught value is this one, because this is in the form of here epsilon naught plus epsilon bar here and to the power n. This is in this form. Okay, and here this is the k. This is the exact formula. So this one is also given, and this is coming from the derivation. Okay, beta and all these things. So if you will replace beta with in the term of a strain, epsilon 2 and epsilon 1, and if you will replace all this value, and if you are getting this direct T1 value and beta value for plane strain mode, beta value is 0. this is a standard case, one of the case, and alpha value is half plane strain mode. And this is well derived in the class and previous lecture. This all value are derived like how this is coming. If you have doubt, we can discuss, but for now, we are just taking this value directly. Okay. Now, this if you are putting all this two value for plane strain, just keep this thing in mind. This is only applicable for plane strain case. Plane strain case. Okay. So don't confuse. So if you are putting this value, we will get the traction. T1 traction, major traction, whatever this value is coming, this one is the traction. And you can also you can also call it a tension here, tension also, major tension. So the unit of this is generally in Newton per mm. Okay, so don't confuse. This is also called a traction. So tension generally in book and all, it is given in Newton, like it's a unit of force only. Okay, so but here tension means traction. So Newton per mm it is given. Okay. No, all values are given. K is given, T naught initial thickness is given, and we have calculated this value from here directly. And this one, but this value is also given. Like you can see here, epsilon naught. This value is directly we can take from here. And n is also given. N this value power. Okay. If we will put all this value in the formula, we will get directly the traction value. Okay. So this is the traction value. So I hope this is clear because this is directly it's coming from the formula. So we will move to the next question. And you can, if you want detail, you can go to chapter number 4. Chapter number 4 in Mersnack book, where stamping and all process are given. Stamping, coining, all are given there. Okay. So going to the next question. Now, in the next question, it is given there, what is the value of beta when a material follows this rule, this power rule? Okay, this rule. So in this equation, what is happening to beta value? This is in the question they are asking what is the beta value. So if you will see the previous equation like here in this equation, the same equation is coming again here in this question. Okay, so same equation is coming, just we have to put the standard case. Okay. So for plane strain, this condition is coming when? In what condition this will come? So just we have to check. So if we are putting beta equal to 0 and alpha equal to half, just in a previous question we have derived. So here, this is the traction value we got. And traction, traction value is the sigma 1 into T, T1 equal to sigma 1 into T. And if we, and this one is the stress sigma 1, and effective stress if we are finding in terms of sigma 1 in terms of effective stress. So this is the formula 2 by root 3 that is already derived. Okay, so if we are going to separate this sigma 1, sigma bar, so this is going to come in this form. So how we are going step by one back calculation we are doing from here to here, means like suppose we have this formula is given. If we are going back to this, we will get sigma 1 and sigma 1 from here to we will get T1, and from T1 we will come to here and from here. So no need to go to here, we will stop here. And here we know this formula in the previous question itself, when we put the beta equal to 0, then this came from here to here. So obviously beta is going to be 0 for this equation. So finally we will get this in form of this when beta equal to 0. So beta equal to 0 and alpha equal to half. If alpha equal to half, then this is the case of plane strain mode. Plane strain mode. Okay. The previous question it was given here. Plane strain mode here you can see. So don't be confused. Okay. So plane strain mode. plane strain mode. So I hope deep tension in a blank holder blank holder location is found uh, 260 kilonewton per meter. This is again given in the term of traction or tension per unit length. Find the blank holding per unit length required in the coefficient of friction is given. How, first of all, I would like to explain this question, how you will visualize this. So have this seat, you have this. So we are holding, like this, and we are pulling like this. This tension is given. So when this is in this direction, when this is flowing in this direction, and something is there here to hold this, some here is there to hold this part. So because of the surface contact here, we have a frictional force in direction. So friction is always in the opposite of the sliding motion. Sliding is in this direction, so friction will be in this direction. So one friction will come here on this surface and another will come and on this surface. If this holding force is B, it is denoted by B here, blank holding force. And this is also called a normal force because this is the normal to the surface. And write it. Okay. So friction force, you are saying friction force is again into normal force. Normal force is here B, so we can write mu directly. Okay. This is the friction force. So this mu top surface and mu bottom surface. What is this tension TA T1 E? One just a notation, don't worry. What is this tension? So this, if this is the equilibrium condition, then this formula will be applicable. T1E this plus this into mu. Now, what is the B? So just we'll take this side, we'll get this. Now T is given, mu is given. So we'll just put that formula, we'll get this 260 divided by 2 into 0.01. We'll divide, we'll get 1300 kilonewton per meter. Okay, we can convert it into per kilonewton per mm also. Per mm also we can convert. Just we have to divide bit by 1000. We'll divide by 1000, it will come 0.3 mm. Yeah. Now, I hope this is clear because it's very simple. And now we can see the next problem. Whatever question I am given this assignment number, this is all are coming to all are there in this book, following this book, Marciniak book. They're very good for the seed metal forming, and professor doing this book online course. Please follow this book, and this book only chapter number 4, chapter number going with chapter number. Find there. Question. Coming to the next problem here, it is given here. Find the major tension at a point A in the seat undergoing stamping in the tension at a near 197. The angle of trap is 17.5 degree. having coefficient of friction as a 0.1. Find the answer in kilometers. So again, this is a very simple question. And if all this problem is like the mechanics, engineering mechanics problem, or familiar with like this type of problem, this was there, and once belt was going like this, and this is the center. This one here setting like this. So one was tension side and one was slack side. Suppose this is T1 and this is T2. Already you have derived T. What was the T by T2 theta? 1 by T2 e to the power theta. This was like this. Was the coefficient of friction, and theta was the angle of wrap here. Same way in this sheet metal forming also same kind of derivation is there. So please follow that derivation. Here you can see tension at the point O. Again, like one side tension is given, T naught is given, and wrap angle is given theta equal to 17.27. So whenever theta we are putting here, we cannot put it in degree. So we have to convert in the radian. So always you put the radian means theta into pi by 180 this value. Into pi by 180. Convert in radian. Okay. So here it is converted here. So once we will convert, we will get this value. And now coefficient of friction is again given. So find the major tension at point A. So major means T1. Okay, and here it is given T2. This one is the T2 value. Okay, which is the side with increased tension due to the friction. This side the high tension side. This is the slack side. If you have remembered engineering mechanics or dynamics of machine chapter, seat belt, pulley, and all. So this formula you can easily get whatever I have written here, same formula. Okay, only this T2 is multiplied here. So you will get this if you are putting all this value. So we can find the final solution after the just calculation. This 197 we are getting from here. It is given, and friction is given, and we have calculated theta in radian, that is also given. So if you are putting all this value, the approximate answer will come 203.0 kilonewton per meter. This was a very simple question, and I hope this is clear. This is very simple, so there is no doubt about this. It's already this type of question you have solved in mechanics. So coming to the next problem. So here, again, in the previous question, like question number 4, like previous question only, last question related, this question is related with the last question itself. So what is given here, find the major tension at point B with respect to O mentioned in the previous question. Okay. The previous question is forget about point O and we just keep this thing in mind like tight side and slack side. Okay, so again we have in the previous question whatever it was given, this one was the slack side. We had to find out the tight side. Okay, so here if you are following this question, like T naught again it is given 197 point something this value. Yeah, here. Not sorry. Yeah. So here T naught is given 197 from the previous question. We are taking this value, and now this time only change is theta. Now it is 60 degree. Initially, what was the theta? Initially, it was 17 point something degree. How much? It was 17.25 degree. 17.25. And now we have theta equal to 60 degree. This one is the change only in this question, nothing else. So we will convert into the radian and the coefficient of friction is again given. So we have to find out the major tension. So major tension, again same formula we are going to use. And if we are just changing the theta value, then we will get the uh, right side tension. So this is coming nearly 208. So here theta is higher, and in previous case theta was lower. So in the previous case it was 203. It was lower than now we are getting 218. So it's directly proportional to, you can say, the theta value. Okay, if theta will change, so this value will also change. So I hope this is clear, because this was a very simple question. All are from the assignment number 4. So basically what we learned here is a stamping process and seed drawing process. Like this type of problem is there. Suppose we have a block like this, and we are holding in a die. Like suppose this is one of the die like this. Okay, this is die like this. So we are applying some force to hold this, and we are pulling from this side. So at this surface, we have some frictional force. At this surface, we have some frictional force. So whatever force we will apply, suppose we are applying P, and here friction is given here, at both the surface. This is mu, if this is given. So, and this pressure, this force is suppose normal force. The quotient is given blank force B or whatever. So we can just take F. So this is the force what you are applying. So this type of problems directly you can write what is the T. So T is 2 times of F, 2 times of mu into F. Mu into F. So one problem was like this, simple engineering mechanics. Another problem was like, suppose we have a die, circular die, and we have a seat, like a strip is there like this. The strips are there, and this strip is passing through a circular die or pulley or whatever it is, you can just think. And we are applying tension like this. Suppose this is T1 and this is T2. Okay, and this angle is given. So in same way, what you are deriving for plus pulley built problem, like one big pulley was there, one small pulley was there, and you had to find out the center distance and all, and the belt was passing through from here to here. So for this derivation, we just derived all this formula. T1 by T2 was T1 by T2, T1 by T2 was e to the power mu into theta. Okay. For V welt, it was theta by mu by sine theta. It was for V welt and all. So for simple, we are just taking here for normal belt, plain pulley and all. So this formula was given. So same thing we can use in sheet metal forming process here, whatever forming is coming. So here it was T by T naught, this one T1 or T naught by have mu into B, this formula. B was the blank, sorry, mu into theta. So we can apply this formula to find out this. So one of second problem was like this. So two question was there from two question were there from this formula only. And what else we learned in the first question? Yeah, first question we found out the traction force. Traction, what was the traction? Major traction force, and a big formula, big derivation was there. So we directly used the main learning point was there. What was the condition for plane strain mode? Plane strain mode. What was the beta and alpha? This was the main learning from that question. So beta is 0 for plane strain mode, and alpha is 1/2 that we have derived this, and beta is nothing but your ratio of a strain minor by major axis, minor strain by major x strain, major direction is minor and major direction. Same way, alpha is the ratio of stress. So this one was sigma 2 by sigma 1. So I hope all these things are clear to you. If any doubt, we can discuss in the online class. So thank you for attending this. So we'll meet with the next assignment number 5. And I hope in the next class we will discuss some more basic of sheet metal stamping process. So some more processes are there, like that is still remaining. So we have covered drawing process, coining process, stamping process. The little bit initially we covered about the rolling and all, but some numerical problems are still to be done from sheet metal rolling process, while drawing process is not covered yet. So maybe in the next class we will cover the wire drawing and all. So we'll see in the next class we will cover. So thank you. We'll meet in the next class.